Today we'll be discussing motion in physics. Motion is the change in the position of a body with time. It is caused by force. Force, of course, we know is push or pull. The study of motion with the force that causes it is called dynamics. While the study of motion without regarding the force that causes it is called kinematics. Dynamics tells us why objects move the way they do, while kinematics focuses on how objects move. In this lesson, we will focus on kinematics. These are the fundamental types of motion in physics. 1. Translational motion. 2. Rotational motion. 3. Oscillatory motion. 4. Circulatory motion and random motion. We discuss them one by one. Translational motion is motion in a straight line or a curved path in which all parts of the body move the same distance. Translational motion is divided into two, which are rectilinear motion and curvilinear motion. Rectilinear motion is motion on a straight line. Example, a car racing from one point to another in a straight line. Or a book sliding off an inclined plane from one point to another. This is an example of an inclined plane. This book is sliding down from this particular point to this point, and you can see that it's in a straight line. So that is an example of rectilinear motion. And when a car moves from point A to point B, this is a straight line motion. The car moving from this point to this point. So these are examples of rectilinear motion. An example of curvilinear motion is stone projected upward. Like this boy here threw up a stone, and the stone traced a curved path on its motion. That is an example of a curvilinear motion. Rotational motion is the motion of an object around a fixed axis, where different parts of the object move through different axes. Example is a spinning wheel. Circulatory motion is a specific type of rotational motion where an object moves in a circular path at specific distance, that is fixed distance from a given point. An example of that is the circular motion of the ceiling fan, the motion of satellites orbiting a planet. An oscillatory motion is a to and fro type of a motion, or a repetitive back and forth type of motion about a central point. An example of oscillatory motion is the motion of a simple pendulum or a vibrating spring. For instance, a vibrating spring, this is its kind of motion, to and fro. It will come and go back, come and go back. That is an example of what? Oscillatory motion. While random motion is a zigzag form of what? Motion. Take for instance, we see this in Brownian motion. This is an example of random motion. It don't have particular routes. It can go any direction. That is the motion of a particle of a gas. Any motion that repeats itself at regular time interval is called periodic motion. At this point, having explained different types of fundamental motion, what we are going to look at is what concepts associated with straight line motion. These are the terms that we are going to be using in the discussion of the motion in a straight line. We have to explain them one by one. The first is distance, followed by position, then displacement, followed by bearing and direction, then scalar quantity and vector quantity. Let's pick distance. Distance is the measure of length between objects or points without regarding the direction. It only refers to the total magnitude and does not account for the starting or the ending point. That is where the object started or ended. So the value of distance can only be 0 or positive and never what? Negative. Since it does not indicate any direction, it means that distance is a scalar quantity. Position. The position of a body in space can only be described with reference to a known position of another body. And to do this, we have to draw two lines that are perpendicular to each other at a point O, called an origin, such that the OX and OY will be the axis of reference. We will use this to illustrate what we are saying. This is the position, this is the body, the point we are talking about on a space. Now, this is a known position of another object, O, which we call the origin because we know the position. So this is now y-axis and this is what? X-axis. The OY now makes the y-axis and the OX makes the x-axis. By convention, we know that distance, any point from the origin to the right of the x is positive, while points from the origin to the left of the x are negative. The points from the direction of, that is upward above the origin, are positive, and any values here, any point here is negative. We can now determine and specify the position of K using the coordinates. You can say that along the y-axis, we have units 1, 2, 3. Along the x-axis, we have units 1, 2, 3, 4. And the point K is at position 2, that is unit 2, along y-axis. And at position, you can say that along the x-axis is in between 2 and what? 3. At the midpoint of 2 and 3. So is at 2.5 along the y-axis. So the coordinate now tells us that along x-axis, always note that the x coordinates used to come first, then followed by y coordinates. So in this case now, it's telling us that along the y-axis, the position K is at 2 units. And along the x-axis is at 2.5 units. Because if from here to here is 1, so and is at the center, it means that for us to get this place, you divide 1 by 2. So we have 1 divided by 2, and that will give us what? 0.5. And that is the reason why we have 2 already here. So to get here, we divide it by 2 to get the center. And that is the reason why we have 2.5. I hope it's clear. Let's assume that we have 2 points, K and P. We can write the coordinates of the K and also write the coordinates of the P. And now we can determine this straight line that is between connecting P and K. Now let's do that. The coordinates of K, we ask ourselves, we said normally that what? X coordinate comes before Y coordinate. So what is the X coordinate of K? K is at the unit what? 2 at X axis. So we have K, comma, then you go to the Y axis. K is at unit 4 at Y axis. So this is the coordinate of K. Then let's look at the coordinate of Y. At Y, at X, coordinate of P, I mean to say. At X axis, P is at unit 4. That is 4 units. Y at Y axis, P is at what? 8 units. So, to determine this position, that is to determine the straight line connecting K and P, what do we have to do? We have the straight line is determined by this formula. This formula, you can see the straight line is equal to, this is the higher number of what? The X coordinates. So that is the 4 minus this minus this plus this minus this. That is exactly what we did. We said this minus this. We started from here and reached here. So the higher number, this minus this, plus this minus this square. Then you get the square root of it. That is exactly what we did. And we got 4.5. Because 4 minus 2 will give us 2 squared. And 8 minus 4 will give us what? 4 squared. 4 squared is what? 16. And 2 squared is 4. 16 plus 4 is 20. Square root of 20 is 4.472 something. And approximately we got 4.5. Displacement is change in position of an object. It has both magnitude and direction, so it is a vector quantity. So let's consider the displacement of this point, body K. The body K was originally at what? The point unit 2 and later moved to unit 6. Displacement is determined by the formula xy minus x0, where the x1 is the final position and the x0 is the initial position. So the displacement here now is 6 minus 2, and that will give us what? 4. Okay, so depending on the units, if it's meter, then you write 4 meters. Bearing and direction. We have 4 cardinal directions, which are the north, south, west, east, and west. In stating the direction of a given point, we state the angle in relation with its what? Cardinal direction. Example. Using these 2 examples, we can illustrate what we have just said. That K is at north 60 degrees east. It means that from the north, A is at the point, that is move 60 degrees, then you get the point point K. You can see this is north, then you move 60 degrees. This is the point K. That 60 degrees is towards what? The east. Then P is at the point south, 70 degrees what? West. So if you stand at the south, you move towards the west and you move 70 degrees, then you will get the point P. I hope it's understandable. In other words, using clockwise direction, one can just say that K is at the bearing of what? 60 degrees. The bearing of K is what? 60 degrees. And in that case now, the bearing of P will be what? From here, we are moving clockwise. From here to here is 180 degrees. Then you add this what? 70 degrees to it. And that will give 180 plus 70. That is 250 degrees. Okay? Degrees. Scalar quantity. Scalar quantity are the quantities. Scalar quantity is the quantity that has only the magnitude. It can be specified by only the number and the units. That it has only magnitude, it has no direction. Example of scalar quantity is energy, temperature. Vector quantity is the quantity that has both magnitude and direction. You need the unit, the number, and the direction to specify vector quantity. Examples of vector quantities are the first, acceleration, the velocity, displacement, and the rest of them. At this point, we can recall that we learned the meaning of motion, types of motion, that is the fundamental types of motion in physics, the concepts associated with motion in straight line. The next lesson will be diving into the calculations in the motion. Thank you. Answer these following questions and hand in. See you in the next class. If you like this video, click on the subscribe button, give it thumbs up, and click on the notification bell so that whenever I upload new video, you will be notified. Come on, watch.